We remain always incomplete without God's blessings. Now, as we begin, I invite Ms. Leena Dinja, head of the department, to welcome the gathering.
Respected Principal, Reverend Dr. Sister G.G. Jonama Savior, Chief Guest of the Day, Dr. Jojo PJ, Principal, Fatima Mada National College, Dr. Milan France, Associate Professor, Department of English, dear teachers and my dear students. Good morning, everyone. Since the last 16 months, we have all been pushed inside our homes due to the ongoing pandemic. However, I am glad to say that this has not stopped us from offering our students with an arena to nurture their co-academic and extracurricular skills. With shared passion and sheer contribution from the staff and students of the department, we hosted many splendid events last year. I am certain that this year also will not be different. On that note, let me get started with my duty of welcoming you all. First and foremost, let me welcome our beloved principal, Reverend Dr. Sister G.G. Jonama Savior, who is our pillar of strength. Sister has always been extremely encouraging to all matters of the department. Sister, it is your sense of commitment which creates an apt platform for our students to grow. With a thankful heart, let me welcome you to this inaugural ceremony.
Thank you.
It is indeed an honor that we have Dr. Jojo PJ with us today as our chief guest. Let me take this opportunity to introduce him to all of you. I have known Dr. Jojo right from my post-graduation period. It is with great fondness that I remember our college days when Dr. Sheena Seeger, Dr. Jojo, and I were classmates. Right from then, Jojo showed excellent caliber in academics. He was a student for whom everyone had high expectations for. Hence, it is no wonder to me seeing all the achievements Dr. Jojo has accomplished. He is currently the principal of Fatima Mada National College, Kollam. He is also a former professor of applied physics in Papua New Guinea University of Technology and visiting faculty in University of Malaya, Malaysia. Currently, he also serves as a recognized research guide of University of Kerala, Mahatma Gandhi University, Bharatiyar University, and University of Malaya, Malaysia. Dr. Jojo has more than 100 publications to his name, and 15 students have awarded their PhD under his guidance. Dr. Jojo is the recipient of most prestigious Saint Berkman's Award for Best College Teacher in the state of Kerala and the Professor Sivaprasad Memorial Best College Teacher Award for the year 2012. With immense pride and pleasure, let me welcome you, Dr. Jojo, to this inaugural function.
Thank you, Dr. Leena. Thank you.
Next, let me welcome Dr. Milan France, Associate Professor, Department of English, who is delivering the felicitation speech today. Dr. Milan has always extended her unconditional support in all our activities. Hearty welcome, dear Dr. Milan France.
Thank you, Ms. Leena.
I also welcome all the faculty members and HODs of various departments who have joined us today. Welcome, dear teachers. Next, I welcome our vibrant association coordinators, Dr. Vimala George, Mrs. Jonas VC, and Association Secretary, Ms. Dorita Mary Mendes. Their hard work is the driving force that makes all our activities of the association successful.
Thank you, Ms.
Welcome my most beloved colleagues of the department, without whom any association activity would not be possible. Welcome, dears. The duty bestowed upon me wouldn't be complete if I do not welcome our loving students who is the heart and soul of our department. Welcome, dear children. Let me conclude by reminding you students that the association is your platform to showcase your skills and talents. Wishing you all the very best. Once again, welcome everyone. Thank you.
Thank you, ma'am. Next, I humbly request our dear Principal, Reverend Dr. Sister Gigi Jonama Xavier for the Presidential Address.
Thank you. A warm good morning to one and all. ഇന്നത്തെ നമ്മുടെ വിശിഷ്ടാതിഥി ഫാത്തിമ മാത നാഷണൽ കോളേജ് പ്രിൻസിപ്പൽ ഡോക്ടർ ജോജോ പനക്കൽ സർ, ആലുവ സെന്റ് സേവിയേഴ്സ് കോളേജിലെ ഫിസിക്സ് PG ആൻഡ് റിസർച്ച് ഡിപ്പാർട്ട്മെന്റ് ഹെഡ് ഓഫ് ദ ഡിപ്പാർട്ട്മെന്റ് പ്രൊഫസർ ലീന ഡീഞ്ച, IQC coordinator and former HOD of Physics Department, Dr. Sheena Xavier, other faculty members of Department of Physics, Dr. Milan France, senior faculty member of English Department, and my dear students. Physics Department 2021-22 അക്കാദമിക വർഷത്തെ പ്രവർത്തനങ്ങൾക്ക് ഇന്ന് ഔപചാരികമായ തുടക്കം കുറിക്കുകയാണ്. ആദ്യമേ തന്നെ ഞാൻ ഫിസിക്സ് ഡിപ്പാർട്ട്മെന്റിന്റെ വകുപ്പ് അധ്യക്ഷയെയും അതർ ഫാക്കൽറ്റി മെമ്പേഴ്സിനെയും ഹൃദയപൂർവ്വം അഭിനന്ദിക്കുകയാണ്. കാരണം ആലുവ സെന്റ് സേവിയേഴ്സ് കോളേജിലെ ഒരു കരുത്തുറ്റ ഡിപ്പാർട്ട്മെന്റ് ആണ് ഫിസിക്സ് ഡിപ്പാർട്ട്മെന്റ്. അധ്യാപന പരിചയവും മികവുമുള്ള ധാരാളം ടീച്ചേഴ്സ് ഉള്ള ഒരു ഡിപ്പാർട്ട്മെന്റ് ആണ്. എല്ലാ വർഷവും വളരെ കൃത്യതയോടെ ഡിപ്പാർട്ട്മെന്റിന്റെ ഇയർ പ്ലാൻ റെഡിയാക്കുകയും ഓരോ വർഷവും വ്യത്യസ്തമായ പരിപാടികൾ ആസൂത്രണം ചെയ്യുകയും ഏറ്റവും മികവുറ്റ റിസോഴ്സ് പേഴ്സൺസിനെ കണ്ടെത്തി കുട്ടികൾക്ക് പരിചയപ്പെടുത്തി കൊടുക്കുകയും ചെയ്യുന്ന ഡെഡിക്കേറ്റഡ് ആയിട്ടുള്ള നല്ല ടീച്ചേഴ്സ് ഉള്ള ഒരു ഡിപ്പാർട്ട്മെന്റ് ആണ്. ഈ വർഷവും ഔപചാരികമായ തുടക്കം ഇന്നാണ് കുറിക്കുന്നതെങ്കിലും ഒട്ടേറെ പ്രവർത്തനങ്ങൾ ഇതിനകം അവർ നടത്തി കഴിഞ്ഞു. അതുകൊണ്ട് തന്നെ ഈ വർഷം പുതിയതായിട്ട് ഹെഡ് ഓഫ് ദ ഡിപ്പാർട്ട്മെന്റ് ചാർജ് എടുത്തിരിക്കുന്ന പ്രൊഫസർ ലീന ഡീഞ്ഞയുടെ നേതൃത്വത്തിലുള്ള മുന്നേറ്റത്തിന് എല്ലാ ഭാവുകങ്ങളും ഞാൻ ആദ്യമേ തന്നെ നേരുകയാണ്. ഇതിനു മുൻപും ഡോക്ടർ ഷീന സേവ്യർ HOD ആയിരുന്ന കാലത്തും ഡിപ്പാർട്ട്മെന്റിനെ വളരെ നല്ല രീതിയിൽ മുന്നോട്ട് കൊണ്ടുപോകുവാനും ടീച്ചേഴ്സിനെ ഒരുമിച്ച് ഐക്യത്തോടെ എല്ലാ പ്രവർത്തനങ്ങൾക്കും ചുക്കാൻ പിടിച്ച് ഡിപ്പാർട്ട്മെന്റിനെ വളരെ നല്ല രീതിയിൽ നയിക്കുവാനും ഡോക്ടർ ഷീന സേവ്യറിനും സാധിച്ചിട്ടുണ്ട്. അതുപോലെ ഓരോ ടീച്ചേഴ്സും അവർ തങ്ങളുടെ മുഴുവൻ എനർജിയും ഡിപ്പാർട്ട്മെന്റിന് വേണ്ടിയും ഈ സ്ഥാപനത്തിന് വേണ്ടിയും ചെലവഴിക്കാൻ സന്നദ്ധരായിട്ടുള്ള ടീച്ചേഴ്സാണ്. വളരെ സന്തോഷം. ഇന്ന് നമുക്ക് വിശിഷ്ടാതിഥിയായി ലഭിച്ചിരിക്കുന്നത് കൊല്ലം ഫാത്തിമ മാത നാഷണൽ കോളേജിലെ പ്രിൻസിപ്പൽ കൂടിയായ ഡോക്ടർ ജോജോ PJ സാറിനെയാണ്. ഞങ്ങളുടെ മദർ ജനറലും ആലുവ സെന്റ് സേവിയേഴ്സ് കോളേജിന്റെ ജനറൽ മാനേജറും ഫാത്തിമ മാത നാഷണൽ കോളേജിലെ മുൻ പ്രിൻസിപ്പളുമായ ഡോക്ടർ സൂസമ്മ പറഞ്ഞ് ഞാൻ ഏറെ കേട്ടിട്ടുള്ള ജോജോ സാറിനെ ഈ ഓൺലൈൻ പ്ലാറ്റ്ഫോമിലൂടെയാണെങ്കിലും കാണാൻ സാധിച്ചതിൽ വളരെ സന്തോഷം. ഈ കഴിഞ്ഞ 2 ദിവസം കൂടി മദർ ഇവിടെ ഇന്റർവ്യൂവിന് വന്നപ്പോൾ എന്നോട് ജോജോ സാറിനെ കുറിച്ച് പറയുകയായിരുന്നു. വളരെ വിനയമുള്ള ഒരു സർ, അതുപോലെ നല്ല എഫിഷ്യന്റ് ആയിട്ടുള്ള കാലിബ്ര ആയിട്ടുള്ള ഒരു സർ. ഫാത്തിമ മാത നാഷണൽ കോളേജിന് കിട്ടിയിട്ടുള്ള ഒരു നല്ല പിൻഗാമിയായിട്ട് തന്നെയാണ് സിസ്റ്റർ സൂസമ്മ ജോജോ സാറിനെ പരിചയപ്പെടുത്തിയത്. അതുകൊണ്ട് തന്നെ ജോജോ സാറിനെ കാണണമെന്നൊരാഗ്രഹം ഉണ്ടായിരുന്നു. അടുത്തു തന്നെ എനിക്ക് ഓൺലൈൻ പ്ലാറ്റ്ഫോമിലൂടെ ആണെങ്കിലും കാണാൻ സാധിച്ചതിൽ വളരെ സന്തോഷമുണ്ട്. ആലുവ സെന്റ് സേവിയേഴ്സ് കോളേജിലെ മുഴുവൻ അധ്യാപകരുടെയും പ്രത്യേകിച്ച് ഫിസിക്സ് ഡിപ്പാർട്ട്മെന്റിലെ അധ്യാപകരുടെയും വിദ്യാർത്ഥികളുടെയും പേരിൽ ഈ ഓൺലൈൻ പ്ലാറ്റ്ഫോമിലേക്ക് വ്യക്തിപരമായിട്ട് ജോജോ സാറിനെ ഹൃദയപൂർവ്വം ഞാൻ സ്വാഗതം ചെയ്യുന്നു. ഇന്ന് നിങ്ങൾ തിരഞ്ഞെടുത്തിരിക്കുന്ന വിഷയം, സാറിന്റെ പ്രിയപ്പെട്ട വിഷയം, സാറിന് ആധികാരികമായി സംസാരിക്കാൻ കഴിയുന്ന ഒരു വിഷയമാണ് ലേസർ ആൻഡ് ഇറ്റ്സ് മെഡിക്കൽ ആപ്ലിക്കേഷൻ. ഇത് വളരെ സന്തോഷം തോന്നി. കാരണം കാലിക പ്രസക്തമായിട്ടുള്ള ഒരു വിഷയമാണ്. നമുക്കറിയാം ഇന്ന് എല്ലാത്തിനും ഇന്ന് ലേസർ ട്രീറ്റ്മെന്റ് ആണ്. കണ്ണുകൾക്കാണെങ്കിലും നമ്മുടെ മുഖത്ത് ദീർഘകാലമായിട്ടുള്ള ജന്മനാ തന്നെ ഉള്ള പാടുകളും മറുകുകളും ഒക്കെ മാറ്റുവാനും അതുപോലെ ട്യൂമർ, ക്യാൻസർ തുടങ്ങിയിട്ടുള്ള ട്രീറ്റ്മെന്റുകൾക്കുമൊക്കെ ഇന്ന് ഫലപ്രദമായ ഒരു ചികിത്സാ രീതിയാണ് ലേസർ ട്രീറ്റ്മെന്റ്. അത് ഇന്ന് കുട്ടികൾക്ക് ഏറെ അറിവ് പകരുന്ന ഈ വിഷയം നിങ്ങൾ തിരഞ്ഞെടുത്തതിലും വളരെ സന്തോഷമുണ്ട്. ഇതിന്റെ എല്ലാ പ്രവർത്തനങ്ങൾക്കും നേതൃത്വം നൽകുന്ന ഫിസിക്സ് അസോസിയേഷന്റെ എല്ലാ ഭാരവാഹികൾക്കും സ്റ്റുഡൻസിനും ഞാൻ അഭിനന്ദനം അർപ്പിക്കുന്നു. അതുപോലെ തന്നെ ഇനി മുന്നോട്ടുള്ള നിങ്ങളുടെ ഈ അക്കാദമിക വർഷത്തെ എല്ലാ പ്രവർത്തനങ്ങൾക്കും വിജയം ആശംസിച്ചുകൊണ്ട് ഞാൻ നിർത്തുന്നു. നന്ദി, നമസ്കാരം.
Thank you, sister.
Thank you.
So we move on to the inauguration. To grace this occasion and add to the charm of it, we have with us the very respectable Dr. Jojo PJ, Principal, Fatima Mata College, Kollam. Sir, I hand over the session to you for the inaugural address.
Thank you, Reverend Dr. Sister G.G. Joan Xavier, the Principal of the College, for showering a lot of good words upon me, as well as Dr. Leena Dinja, your other department. As you know, probably, I'm originally from Ernakulam, though I'm here in Kollam for the last 28 years. I'm originally from Ernakulam, and I had my college studies in St. Paul's College, Kalamasheri, for 7 years. After that, only I moved to North for a current PhD. Later on, I joined Fatima College, and I'm here now. Now, before going into the subject, lasers, first of all, I would like to congratulate the Department of Physics, led by Dr. Leena Dinja, Dr. Sheena Saver, and all, for organizing such a beautiful function on this morning on behalf of the Science and Physics Association. Actually, as Dr. Leena pointed out correctly, we have been, I would say, not locked down. We are all locked up at home. Not really locked down. We are locked up. We cannot move. We cannot enjoy. We cannot even go to our colleges. I really feel pity to the students of these days. The days they should have really enjoyed, in the sense academically as well as socially, because college studies are not simply just studying or mugging up things. We learn a lot of things at the college as well as outside our home. I used to say to the parents, not to the students of my degree classes, that you should allow your children to go out of our grips, in the sense that they should go outside Kerala or even outside India to have higher education. And then only we will grow in the sense your personality will grow, how to live. That is the most important education we should have, not simply the bookish knowledge. We should be able to get to know how things are moving. The youth actually feel very difficult. That's why we see a lot of suicides and all around us, because you have no strength of mind. To get that, we should naturally go out of the hands of your parents. So my humble request to the young graduates of St. Xavier's College, Alua, is that you ask your parents, if as far as possible, you try to pursue your higher studies. Outside your university, or outside the state, or if possible outside our country. Congratulate the department for organizing this function, and I should wish all the best for the colorful activities you are planning this year on behalf of the Physics Association. It's very encouraging that even in these days of COVID, even if we are under the lockdown, you are coming out with programs, with ideas, and which are beneficial for the students. So I first of all, I congratulate the department, each and everyone, and wish the association a great time during these difficult days of pandemic. Then I think I should declare that this association activities of association open. Thank you very much.
Thank you, sir.
Thank you, Dr. Jojo.
Thank you so much, sir. Now I request Dr. Milan Franz, Associate Professor, Department of English, and our constant well-wisher to felicitate the gathering.
Good morning to all. My greetings first goes to my beloved principal, Reverend Sister Shalini and Dr. Jojo, my dear friends, Professor Leena, Dr. Sheena, and all other dear friends in the Department of English, and my dear students. Well, at the beginning, I would like to say that nothing happens in life without a reason, or in other words, nothing happens accidentally, I believe so. So if I'm here, there's a reason for it. And I should say it is because of the love and the cordiality and the kind of fraternity that I keep with the physics department. I've been always in touch with, even though there are many departments in the college, there are certain departments which are closer to your heart than other departments. It doesn't mean that I don't have relations with others, but there are some departments which are more dear to you. And I have always had a beautiful relationship with the physics department. Even now I maintain that close affinity with all the faculty, especially with the former faculty, and also with all the faculty now serving in the department. And this year, something is special because one of my greatest friends, Leena Miss, she has taken over as the head of the department. And again, she, along with another friend of mine, Dr. Sheena, both of them are retiring. So I take it as an honor to be here to felicitate on this auspicious occasion of the inaugural function of your activities. So before speaking something, before giving a kind of felicitation or good wishes, I would like to say a few words about the prospect of knowledge, or about the meaning of pursuit of knowledge. We all know that we are engaged in a kind of journey, or I should say a kind of pilgrimage for attaining knowledge. But the kind of knowledge and the information that you acquire through this kind of academic endeavors, I should say they should be transformed into a kind of awareness, knowledge leading to awareness, knowledge leading to a revelation, or in other words, in Malayalam we call it jnanam. And for information we call vijnanam. അപ്പോൾ വിജ്ഞാനത്തിൽ നിന്ന് ജ്ഞാനത്തിലേക്ക് നയിക്കുകയാണ് ഏത് വിദ്യാഭ്യാസ പ്രക്രിയയുടെയും ലക്ഷ്യം. So whatever you acquire here, whatever knowledge that you come to know about during your academic life, that should lead you basically to a kind of awareness about yourself, awareness about your relationship with the universe, your relationship with nature, and especially your relationship with other human beings. So that is what education means. And all our disciplines, because I'm from a humanities department, or from language department, you are in science department, but I don't find much difference between us who are engaged in the same sort of, I should say, we are all engaged in a quest for truth, in a sense. What are you doing? Because in the beginning, sir, from his speech and from all the all the introductory words, I understood that he's going to speak about lasers. So what are you talking about? What are you trying to search for? You are also trying to search for something that will contribute to the betterment of human beings, that will make the life of human beings better, more beautiful, and more harmonious. And so I want to say only this, all the disciplines, whether it is humanities or language or science, commerce, whatever it is, basically that is marked by a covenant of love. And that means that love for others, love for entire human beings, love for nature, love for others. And again, when you learn things like, for example, in science, the basic things that you know about life, and you try to know about universe, you try to know about the basic components of life as such, and you try to analyze that. By analyzing that, you come to know about the relation of man to the entire universe, and that of course makes you a humble human being. That should make you a humble human being, because then you will come to know how silly or how insignificant is the role of man in the whole process of the universe. When you study about solar system, especially in the basics or in the schools, when you study about solar system, you come to understand that ours, or our planet, is one of the one of the 8 planets that are there, and you are only one spot, or you are like a drop in the ocean when you think about it. So you think about your existence, and you understand that you are nothing more than a drop in the ocean, and you come to respect other species, other beings on this earth, and you think that you no longer you have to be anthropocentric. Don't think that human beings are the paramount beings in the hierarchy of creation. There's no hierarchy at all. So that kind of awareness, that is what I meant. So when you learn something, that should basically lead you to an awareness about the basic humanity. Humanity, I mean, not simply about knowledge about human beings. I mean, the kind of openness towards everything, the kind of openness towards each and every aspect of universe. Even a blade of grass is important. Even an insect is important. They are having the same status as human beings in this world. So here, I am sure Dr. Jojo will be speaking about the laser, and as the principal was explaining, how it is important in our lives. So each and every endeavor, or each and every attempt to acquire knowledge, should contribute something to others, something to the humanity, and it should ultimately lead to a better, harmonious, beautiful life altogether. Okay, so, and again, we are also doing that. We humanities, we study about poor, marginalized, the suffering, etc. So when you learn literature, you have to understand it. You should be able to identify ourselves with others, sympathize with others, and do whatever we can for alleviating the suffering of others. So this is what I just want to speak about knowledge, pursuit of knowledge, its aim. And so I'm sure that this is a platform, association is a platform, which will give you that kind of openness, where you can not simply, you can rely on your academics, but along with academics, you will take up a lot of other things which are related. But as I said, basically everything is marked by a covenant of love and fraternity. And so I hope that the activities, and I know physics department is always vibrant with a lot of activities. So I'm sure this platform this year, even though we are on online mode, I'm sure they will never make any compromise, because that gives a lot of newer venues, newer opportunities, newer tools and platforms for the students to explore themselves, to do they will surely try to find out newer methods for reaching out to others and for nurturing their own talents, their own basic qualities. And ultimately, that will become a beautiful platform for making the best and for experimenting the best of their potentials. So I wish all the best to all the activities during this academic year. And I'm so happy and honored by the special invitation that has come from the Department of Physics. And I remember, even though I have went to many other departments for many other functions, I'm for the first time here for the association inauguration of the physics department. So this is just an honor for me. So I wish all the best to all.
Thank you, ma'am. Last but not the least, I invite Ms. Dorita, Association Secretary, for the vote of thanks.
Good morning, one and all. Respected Principal, Reverend Dr. Sister Gigi Jodama Xavier, Honorable Chief Guest of the Day, Dr. Jojo Sir, Principal, Fatima Mahda College, Kollam, Head of the Department, Ms. Lena Dinche, dear Sheena Miss, dear teachers, and my dear friends. Let me start by giving glory to the Almighty God for making this occasion a resounding success. Though we are in the middle of this pandemic situation, we could inaugurate the activities of our association for the year 2021-22. We have already started our activities even in these difficult days through the available online platforms. The association has been organizing and conducting many activities such as seminars on relevant topics, career guidance classes, etc., that help us to grow in our entire life. And I'm so proud to be a part of it. All the students have given their active participation in all the programs, and I hope for the same in the coming year. Now, let me move on to the duty entrusted on me. First and foremost, I thank our beloved principal, Reverend Dr. Sister Gigi Jonama Xavier. We are aware of her keen interest and dedication towards the development of her college and her students. With a grateful heart, I thank you for your presence and also for delivering an inspiring speech for us. Thank you, sister.
Thank you.
I take immense pleasure in extending our sincere thanks to our chief guest, Dr. Jojo sir. As Lena ma'am said, he is the winner of the most prestigious St. Berchmans Award for Best College Teacher in the state of Kerala in 2012. We are so glad that we got the right person with in-depth knowledge for inaugurating this year's association activities. I am sure the talk on lasers and its medical application will be a wonderful learning experience for us. Thank you so much, sir, for gracing this occasion.
Thank you.
My heartfelt thanks to our own Milan Miss of English Department for spending her time with us. She has always been with us, actively helping and supporting us in our academics. Thank you so much, ma'am, for your words of wisdom. I also take this opportunity to congratulate her for completing a graceful 25 years in the field of teaching.
Thank you.
And next, I would like to thank our dear HOD, Lena ma'am. Even during these tough times of pandemic, she has been taking initiatives in actively organizing and conducting different programs for our educational as well as cultural development. Thank you so much, ma'am.
Thank you.
We are grateful to our former HOD, Dr. Sheena Xavier, for her constant encouragement and support towards us throughout all the activities. Thank you, ma'am.
Thank you, Derita.
I owe special gratitude to all the teachers from other departments to grace this occasion. Also, I would like to thank our dearest teachers who are always with us in all our endeavors. My heartfelt thanks to Dr. Vimala George and Ms. Janice VC, Teacher in Coordinates of Physics Association, for working as a backbone with us in coordinating all these programs. Last but not the least, I would like to thank each and every one of you for your valuable presence in making this program a great success. Thank you.
Thank you, Dorita. Next, we move on to the talk on laser and its medical application by Dr. Jojo P.J. Sir, I cordially invite you for the session.
Thank you, Dr. Sister Gigi Xavier, the principal of the college, Dr. Lena Dinja, the head of the department, Dr. Sheena Xavier, Dr. Milan Friends, then Miss Derita, all of you, and each and every student and teachers listening to me. I hope this few minutes or half an hour would be some sort of information, new information, or rather an enlightening about the laser and its medical applications. So this is, let us start with the term laser. As we know, light amplification by stimulated emission of radiation is laser actually. So there are several terms. Light is there, amplification is there, stimulation, emission, radiation. All these terms are very, very familiar to us. But when you talk about the amplification, immediately an ordinary amplifier comes to our mind, where we amplify a sound signal. This is a sound signal, a sound wave which is made into an electrical signal like this, which can be amplified to have a greater strength For that, we use a device called amplifier. So we are all familiar with this, how a sound wave is amplified using an electronic device called amplifier. But the question is, how do we amplify light, or what is the mechanism behind it? We cannot simply amplify light like using an instrument like amplifier. So what is the mechanism? Actually, this is an electromagnetic wave. Light, when you say light, it's basically an electromagnetic wave. Electromagnetic wave means it comprises of electric fields and electric and magnetic fields. You can see the orientation from this animation. There is electric field and magnetic field. Electric field is represented by the yellowish sinusoidal wave, and magnetic field. This is the orientation of electric field and magnetic field. And we use radio waves in the case of radio, AM radio, RF, and FM radio. Now we have microwaves. Usually we use it in the microwave oven and radar. We have infrared. What is meant by infrared radiation? They are basically heat radiations. Heat radiations are generally, they're classified as IR. And in visible, there are 7 colors, and it's very narrow. Perhaps the narrowest band of electromagnetic spectrum is our visible spectrum. Only this wavelength we can see. This can be produced by simply accelerating charges. Whereas microwaves, next longer wavelength, shorter wavelength, microwaves can be produced by molecular rotations. Certain molecules, especially gas molecules or liquid molecules, can rotate by themselves. When their rotational energy changes, we can produce microwaves. So that's how you produce microwaves. So molecular rotation, change in molecular rotation produces microwaves. Like that, molecular vibrations. When the vibrational energy of molecules changes, it produces IR. And all these three we get from outer space naturally onto Earth. That visible light, of course. Visible light we can produce by excitation or de-excitation of outer electrons of atoms. This is a general rule, not very, very hard and fast. So, it can be produced by troubling outer electrons of atoms. Like that, ultraviolet radiations can be produced by changing intermediate electrons between their atomic orbitals. X-rays can be produced by rearranging innermost electrons. And of course, gamma rays comes only from the nucleus. It comes from the nucleus. So these are the sources of different electromagnetic radiations. As a physics student, we should be very clear of this electromagnetic spectrum and their sources. Now, let us come to the visible light. See, we have atoms and electrons. Normally, electrons will be in the ground state. Normally. If they get sufficient energy, they can go up to a level, usually we call it excited state. But electrons cannot remain there for long. See, you can think of, suppose you are going to your friend's home. Okay, one of you go to your friend's home. How long will you stay there? There is no hard and fast rule that you should spend only 15 minutes there or 1 hour there. Depending on your level of interaction, you will spend, but there is, of course, a period of time. After that, we will return to home. We cannot remain for long in your friend's home. So like that, these electrons excited will remain for a characteristic time. See, when it is human scale, you say 10 minutes, 1 hour or 2 hours like that. But in atomic scale, this period is about 1 nanosecond, 10 to the power minus 9 seconds. So during that period, this excited electron has to come back to the ground state. That's a normal process, or we call it a spontaneous process. Now, it's very clear from this figure. This is an atom, normal atom, which is a 4 electrons here. Okay. Now this one electron, this is the ground state. Actually, the atom is very happy. There is no excitation. There is no. It's in equilibrium actually. Equilibrium means most comfortable state. But suppose one electron is taken to the outer level like this. It becomes excited, and that is not a permanent state because it troubles the equilibrium. Then this electron, after the characteristic time, as I told, about 10 to the minus 9 seconds, it comes back to its original form, original state. So this is somewhat clearly explained here. A normal atom has electron in the bound state, then it is excited. Okay, after characteristic time, it goes back emitting corresponding electromagnetic wave. This is a basic mechanism. And this has been shown for a hydrogen like that. Now you can see it here, how excitation takes place. It absorbs energy, goes to the excited state, then emits that particular photon, the same frequency or same energy photon. In 1917, he theoretically conceptualized the idea of stimulated emission. Is it clear? So that means the atoms or the molecules should emit only after a stimulation. That means only when we say you emit, then only they should emit. In that case, all the atoms will emit together and they will be in phase and they will have a big wave like this. So that is the point. So here Einstein made a theory of it, and in 1950s, actually the first laser, actually it was not laser, it was a maser. Maser means microwave amplification, that's all. Because microwaves are more probable for lasing action. So that's why maser was first invented. Later, in a few years, laser came in. So the first lasing technique was applied for microwaves, and we produced microwave masers, actually, microwave amplification by stimulated emission of radiation. It was done by passing microwave radiation through ammonia. See, you may wonder, you have taken a medium ammonium, through that you send a microwave to generate a stronger microwave, that is maser. You will see the mechanism. So this is the thing. We have the microwave amplification, the microwave region, maser. In the light region or the visible region, we have the laser, and we are looking for graces, that is gamma ray lasers. You can think of it. Even laser is very strong. If you point a laser to your eye will be destroyed. You know that. Have you ever thought? You see, you have a bulb of 100 watts in your room, 100-watt bulb or 40-watt tube light. Can you look at the bulb or tube? We can. There is no problem. Even for say 5 or 10 seconds, you can look at a bulb or a tube. There is no issue. It will not make any harm to your eye. Of course, some discomfort may be there. More than that, nothing will happen. Whereas if you take a laser of say 0.5 milliwatt, 0.5 milliwatt, not watt, to your eye, the eye will be destroyed. Is this a controversy? Is there something fishy about it? Because you can look at the 40-watt bulb, whereas you cannot look at a 0.5 milliwatt laser. What is the difference? So what is the problem with the laser then? The laser is not only coherent, it is highly dielectric. Therefore, the energy density will be very high. That's why it destroys our cells. Okay, now with this scale of thought, you take the case of graces. Gracer means gamma ray laser. Suppose, imagine, and we can always dream. Suppose you have a gracer. Laser, everyone has this pen like laser. You know that even for 100 rupees or 50 rupees, we get lasers. Now, like that, suppose we produce graces. You can imagine the strength of it actually. You can easily, you can surely say that if you point a laser, if you move a laser across a ship, it will be cut into 2 pieces. Okay. So I hope you understood these 3 terms. What is maser, what is laser, and what is gracer. Suppose we have a molecule. Okay. We give a photon to the molecule. It becomes excited. Correct? So first we excite the molecule. Then the molecule decays by itself. That is why you call it spontaneous, emitting the same photon. Okay, the same energy normally. But suppose this excited atom is exposed with another photon, correct? Then you will get the normal molecule as well as 2 photons. So you may think it's not a big thing because 1 photon you have already given to it to make it, 1 photon you have already given to it to make it excited, and this excited atom by itself will emit. But here, that excited atom is exposed with another photon to get two photons. So there are two things. First of all, you have to keep this molecule in the excited level for a longer time. Then only we can do this. Otherwise, as I told you, in a period of 10 to the power minus 9 seconds, this will happen. It will emit. It will emit by itself in a very short time of 10 to the power minus 9 seconds. So first of all, we have to hold this molecule or atom or medium in the excited level for a longer time. So that is the first challenge. Okay. So if you can hold this molecule in the excited state, and then if you expose a photon, then you will get two photons. Not simply two photons, these two photons will be in phase, whereby their amplitude will be doubled, therefore the intensity will be 4 times, because 2 square, n square. So that is what I explained here. In the case of spontaneous emission, which happens in a period of 10 to the power minus 9 seconds, the resultant intensity will be n times I, the number of atoms into the intensity. Whereas in the case of stimulated emission, which happens in a longer time, see, this 10 to the power minus 9 and this 10 to the power minus 6, it produces intensity proportional to square of the number of atoms or number of molecules. So this is the root or root thing behind the lacing action or the function of lacing. Okay, so this I have explained here. So there are 3 levels you can see. This is the ground state, and this is the metastable state. I told you there should be a longer period. There should be a longer period, and excuse me, 1 second. 1 minute. Sorry, please hold 1 minute. Okay then, sorry. So here you have 3 levels. One is the ground state, second one is the metastable state. This is a new one for you perhaps, and is the excited. So normally for atoms we will have ground state as well as excited state. Suppose our system means atom or molecule or a crystal or a gas or a liquid, whatever be it. Suppose that medium has a metastable state. Metastable state means a state with a longer life as compared to this. Okay, so what happens here? You see, an atom is excited to the excited level. We give energy, we give photon. So it is excited here. Then spontaneously it comes back to metastable state, and this energy difference is small, thereby it will be a non-radiative transmission. The energy will be given as heat or something to the medium. Clear? So I repeat, first an atom is excited to a higher level, excited level. Then by itself, it emits or it comes to the metastable state, not to the ground state, to the metastable state, which has a longer life. Clear? So that means you can excite atoms to the excited level, you can take electrons to the upper level, and they will remain in the metastable state for a longer time. By that time, you can send a photon. You get 2 photons. I told you, not simply 2 photons, these 2 photons in phase, giving a very strong light. So this is the basic mechanism of light amplification. So technically you say you give 1 photon, you get 2 photons, but it comes out as a what you call superposed photon with high intensity. This is a mechanism of lasing. Basic mechanism of lasing. It emits out and it gets 2 photons. I hope it is clear. These are all non-things to you. So for this, we need a medium having metastable state, and that is what we call an active medium. So you give an input, it passes through the active medium, you get an output. And this is the amplifying medium or what we call the active medium. So an active medium should have a metastable state. That's why we have say for example, ruby laser, but we don't have diamond laser. One can ask you in your Viva also, we can produce a ruby laser, we cannot make a diamond laser. Why? Because of the lack of metastable state. We have different atomic lasers, we have different molecular lasers. For example, carbon dioxide laser, ammonia laser is there, but you cannot have nitrogen oxide laser. That's the reason. So here, practically what we do is, we have an active medium with a metastable state. These are two mirrors. One is actually a 100% reflecting mirror. You can say theoretically 100%, practically it's not possible, but let's call it 100% reflecting mirror. So here we have a semi-reflecting, that means partially reflecting mirror. So suppose one photon goes to the active medium like this, then it emits two photons. Because of the lasing action in the active medium, you get two photons. These two photons reflect from the molecule, the reflecting mirror. So they return as such. Then they pass through the active medium, gives four photons now. Out of these four photons, three may be reflected, but because it is a partially reflecting mirror, one will come out. This is only an example. No single photon actually. This is a graphical representation. That's all. So this is actually a working laser. It's a practical laser works. This again is a display animation, how it works. You get some stimulation and it gets clicking it once again. Atom is excited, absorbing the wave. Then it is de-excited, you are receiving the photon. Receiving this photon, it is de-excited. So this will be laser actually. Okay, fine. This is in a larger scale. Now, these are the persons who made first lasers. Ruby laser, helium. It's a practical lasing system. You have a medium here. So, for example, ruby is a ruby crystal. Then you have flash tube, light tube. When they flash, these photons will get absorbed in the medium. They go to excited level. Then de-excite to the metastable state, heating this medium a bit, because it is a non-radiative transition. Then receiving the stimulation, the laser comes out. This is it's a practical ruby laser. You have two mirrors here. Okay, one is perfect and the other one is partially reflecting. And this is the analog system. Explanation of the animation. Now, coming to the characteristics of this, so what is special? We have seen one point that is coherence. And the light emitted from a lasing source or laser is coherent. They are having same phase, therefore they are very strong. And moreover, they are monochromatic because we are playing with single frequency all through. So we get the same frequency, therefore they are monochromatic, so coherent, monochromatic. Thirdly, directional. Because of this system of mirrors, we get high, I think I've shown you this system of mirrors. The light coming out will not be diverged. They will be parallel to these mirrors. Therefore, there is high level of directivity. So here, the laser sources are highly directional. That means they come out as a very narrow beam. They will not diverge much. And lastly, it is bright because of the high intensity. So these are the four major characteristics of lasers: coherent, monochromatic, directional, and bright. Now, I'm comparing laser with some other conventional sources. You have a conventional source like a radio, an incandescent lamp. The point is, what is this? This is wavelength. So that means the source will emit different wavelengths, and the emission is not equal. They are different. They emit different wavelengths. So it's a band of wavelengths emitted from the conventional source. Whereas if you take an LED, the band becomes very small. It's a small range of wavelengths are emitted from the LED. I have shown you a red LED. That means a very narrow band with red color will be emitted by LED. In the case of a red LED, if it is green, it will be green. Whereas if you have a laser, you see, it's very narrow. It's very narrow. That's why you call it monochromatic. See, in your lab, BSc lab and MSc lab, we use sodium vapor lamp. We call it monochromatic, but we know it's not perfectly monochromatic. It has a spread actually of wavelengths. It has a band actually, a narrow band of course. But if it's a laser, there is no question. The band it emits only a single wavelength. So that is the monochromaticity of lasers. So this is the concept. The directionality. Normal source emits in all directions like this. There is no, it is directed like this. There is no directionality. It goes equally in all directions. Light spreads out in all directions. Whereas if it is a laser source, you can see that the spread is very narrow, very small. Narrow means very small. So you can see that it starts like this, and even after kilometers, the breadth of the beam will be, or the width of the beam will be very, very, very small. Now, what are the general uses of lasers? Of course, we will not talk about the medical uses, but they have wide use. We can say we cannot find a field where laser is not used. Okay, right from the CD player to the guided missiles, we use lasers actually. Okay, so some of them are just listed here. Laser DVD players, cutting machines, printers, eye surgery, render work, speed detectors, all these we can use lasers. And I'm coming to the medical uses of lasers. I'm only concentrating 2 or 3 because if I talk about all the medical uses of lasers, it will take a day or more. So I'm just confining to 2-3 applications of medical use of lasers. So these are the most common uses. First, in neurosurgery, neurological problems we can fix using lasers. Okay, administration of cysts, removal of cysts in the neural system, then tumor resection, and metastasis, etc. are some of the uses in which laser is. Some of the uses of laser in neurosurgery. And ENT in almost tonsillectomy, that means removal of tonsils, excision of tumors, we can use lasers. Then excision of granulomas in the throat and all, we can use lasers. Then pneumology, that means in the lungs. Okay, we have bronchoscopy, airway recanalization, tissue coagulations, etc. We can use lasers. These are the. Then you have spine surgery, laser discectomy. That means when there is some problem with the spinal disc, we can use lasers to rectify it. In gynecology, the use is very wide. I listed on the 2 or 3. Then in urology also there are several uses of lasers. Arthroscopy, and even in general surgery, we use lasers widely. Because mostly the advantage of lasers in surgery is they help bloodless surgery actually, and blood won't be shed. Once there is a cut, immediately that cut will be clogged with the coagulated with the blood cells, thereby further bleeding will not be there. Whereas if you have a physical incision, the vessel is open, thereby there will be bleeding. But in this case, the cut vessel will be normally soldered in. So that is advantage with the laser surgery. Now, let me generally say that in medical uses, we have medical diagnosis. You know the endoscopy. Suppose some problem is in our say pharynx or the foot path. They usually use endoscopy. Okay. Then a thick cable will be put into our body where there will be a source of light, usually laser, driven through an optical fiber. So you can see the inner part of our body. So that is the most widely used method of lasers for diagnosis. Then for medical therapies, we can use lasers. For example, there is some problem in the spine or in the vein or somewhere. You can use lasers for heating of the region and canalizing the blocked portions. And the last one is basically medical surgery. Okay, and most importantly, 4 of them I have pointed out here. There are numerous applications. I have just pointed out 4, and we will see only these 4 here in this talk. First one is actually TM. That's called the transmyocardial laser vascularization. Okay? Myocard related to the heart actually. Transmyocard. Trans means the whole heart. It is applicable to the whole heart. And revascularization means if there is a block, that block is released. That is vascularization. So that is one application of laser there. Second one, endovascular surgery, similar to this. Third one, eye surgeries, where 2-3 applications are there. Then in bone or skeletal surgery. So these are the major 4 applications. So first of all, how diagnosis is done? This is a laser source. The laser light comes through a fiber, and I've shown this pharynx. തൊണ്ടയിൽ വരുന്ന ഫെറിങ്സിൽ വരുന്ന ഡിറ്റക്ട് ചെയ്യാൻ വേണ്ടിയാണ് ഉപയോഗിക്കുന്നത്. You have a laser source. Laser light comes like this through an optical fiber. The enlarged portion is shown here. So light comes like this. It's a camera. Camera picks up, and you can see it here. It's a very simple system actually, theoretically. But this is how you see, diagnose things. If there's a block, if there's a growth, or if there's a tumor, like things can be seen using lasers. Now, what happens in the TMR? That is what I have explained here. Suppose there is coronary arteries clogged. Okay, in that case, if the coronary arteries are clogged, it will not be able to deliver sufficient blood, and thereby no oxygen will be given to it. So how we rectify it using lasers? I'll show it here. See, this is a laser source, and this is a heart actually. Okay, actually laser punctures, make small narrow you can say pipes, or you can say canals in the heart like this. So this is a heart actually, and this is the heart vessel, and you can say the wall of it. So using lasers, it makes microscopically narrow channels there. So what happens is, from here blood enters into this. This is actually inside of the heart. So from there, blood will enter into this, thereby rejuvenating the cells here. So that will remove the, this is what really we call it revascularization. Okay, we make narrow punctures here, through which fresh blood enters the vessel. This will penetrate to the muscles in the vessel, and they will supply sufficient oxygen through the blood, and they will be rejuvenated. So otherwise, this is actually a dead region of the cardiac wall, heart wall. So this is one application of it. So here I have explained it here. Endovascular surgery is an innovative, less invasive. That means we don't use any inversion, and we don't make any cut there. It's a procedure to treat problems affecting the blood vessels. Okay. And another method is ballooning. I will show you. See, this is. Suppose you have a vein like this. It's a normal vein. It's a normal vein where the blood vessels, the red dots are actually representing red blood cells. These blood cells can flow in only one direction, and this is how it flows with the control of the valve. This is a valve, so it flows in one direction. What happens in the case of a healthy vein? But suppose there is an aneurysm, a growth in the walls of the vessel. See, what happens is, see, the valves are open. They cannot touch each other to block the reverse flow. So there is flow of blood on both sides. This may complications. But here we need to canalize blood flow only in one direction. So how do we do it? This is done using what you call, you must have heard of balloon surgery. So that is what we do here. This is it. This is the aneurysm, the plaque deposited in the wall, thereby it becomes thickened. And when it is thickened, this vein becomes narrow. So we allow a laser guided fiber to enter in, fixed with a balloon. This is what you call a balloon actually. Oh, I'm sorry. This is what you call a stent with a balloon. I will show another animation, then you will understand. The stent will be kept like this. Okay, we allow Actually, I will show you in the future. I mean, the next slides how really done. This is a basic mechanism. Okay, it goes in near the plate. It is allowed to expand. Then this will be pulled back. Then when it is pulled back, this will be restricted. This is how it remains. Okay, and this is the case. Here there is a block, and from the thigh you enter a fiber, optical fiber with laser, and it locates the region. Then the stent is left here. This is a stent. The stent is left here. Okay, I will elaborate here. You can see that how does it work. See, it expands. Okay, that net-like thing will remain there. See, the balloon is contracted. It is pulled back. So thereby removing the block. Not really removing, you are expanding the vein using the stent. I hope it is clear. So for this, actually, laser is used to locate the region where this stent has to be put. Laser is not really treating directly. I hope it is clear. And this is how it is done. Through the leg, the fiber goes in, and the whole thing is done like this. So really to locate, we need laser sources. Now coming to the eye surgery, the worst thing that can happen with the diabetes is retinopathy. Retinopathy means actually retina is gone actually because the blood vessels will be ruptured and the retina will be permanently damaged, and that will make one blind. So for that, if you can detect this type of ruptures in the cornea, retina, you can rectify it using lasers. See, this is a normal retina. The vessels are there. One point with the diabetes is, one doctor told me that the best thing to see the effect of your diabetes on your body is to see your eye, because eye is the only organ where you can see blood vessels directly. Nowhere else you cannot see blood vessels directly, whereas inside your eye you can see the blood vessels. So that is what an ophthalmologist do. When you go to consult an doctor, he see the retina and he can see the veins here, the normal blood vessels here. If the blood vessels are normal like this, that means there is no problem. But if there is clogging of blood like this or cutting of veins like this can be fixed using lasers. What we do is, theoretically, it is a very simple process. We will focus a laser to this region. Suppose this is a infected region. So we focus a laser beam onto this. Thereby, it will be burned and the vessel will be closed. Thereby, further bleeding. Because the retina will be damaged if the bleeding continues. When the vein is broken or the blood vessel is broken, it will bleed. And the blood will spread over the retina, and that will make us blind. So to get rid of it, once there is a break or once there is a swelling, the doctor can fix it by allowing laser to fall on it, and the laser will burn and will close that blood vessel. There are lakhs of blood vessels, of which if he close 1 or 2, there is no problem, or 10 or 15, there is no problem. So that is what we do in the case of diabetic retinopathy. Somewhat clearer picture is here. Is a laser beam. Okay, laser beam falls onto the retina here. You can see that. Okay, and it fixes here. You can see that. This broken or swelled blood vessel will be closed by using lasers. It's not a very expensive treatment, and it is done even in small clinics now. So another treatment, suppose there is a vessel which is infected like cancer or something, some tumor inside your eye. You cannot open eye and remove it. So using lasers, we can treat it. So for example, here you have an abnormal blood vessel and in a tumor affected blood vessel. What we do is, we send, we circulate actually through the blood, we will inject. a photosensitive dye to our eye, to our vein, and that will reach here. See, you can see that now it has turned into green. Green means a dye, a chemical. Okay, then we expose it to a laser, a cold laser, and thereby what happens is this dye will be activated and it will selectively destruct the abnormal blood vessels. The other blood vessels, it's a very advanced one actually. No other blood vessel will be affected. So just by exposing this laser, you can activate it, and those dye will destroy this tumor. So that is another. And now I think I'm showing some instruments being used for the treatment. And this is some diagnostic things. This is laser-assisted angioplasty before and after. Here you can see the break, here it is rectified. And this is how you check your throat using laser-assisted endoscope. You can see that endoscope. This is a rigid one, this is a flexible one, and you can see the inner vessels. This is a laser surgery for disc. And this is, of course, it's actually a cosmetic surgery. In fact, not a surgery at all. You can remove your hair on the face, or you can rejuvenate skin by exposing to controlled exposure to lasers. It's cosmetic treatment. And while we use lasers, we should have some security. We should take care of something like you should have an eyewear and all these things are listed. Any questions?
Thank you, sir. Now audience can ask their doubts or queries regarding the topic. You can unmute the mic and ask question, or can post your questions in the chat box also. Also, the link for the feedback form is given in the chat box. Please fill it to get the certificate of participation.
Good morning, sir. It was really very interesting talk, and I got many new ideas about the different ways of using laser in medical applications. That was really nice, sir.
Thank
Sir,
you.
I just want to know about the harmful effects of laser. Is it good to have this laser treatment occasionally for the various diseases?
Yeah, normally you mean the eye surgery or laser is safe actually, because it is not like gamma rays used in the nuclear medicine and all. This is really very controllable source of light, thereby there is no harm. It will not destroy other cells.
Yes.
It's widely used, especially in the case of diabetic retinopathy. Even in small clinics, they have lasers for the treatment.
Yes, I have once done the laser eye treatment.
Okay.
And actually, I had done it in the 2006, and that time onwards, 2006, I had.
Okay. Okay. Was it LASIK? Was it
LASIK? Yeah. LASIK.
Okay. That is using laser. They are removing some cells. That is laser.
Yes.
From the cornea. Yes.
And from that time onwards, there were some doubts about the harmful effects.
No, nothing. It will not destroy any of other cells on your eye.
Yes. Thank you, sir.
Thank you.
It was really a wonderful class, sir. Thank you.
Thank you.
Let me invite Miss Adalia Benny of Second DC Physics for the vote of thanks. Adalia.
Yes, ma'am. Am I audible?
Yes.
Ma'am, am I audible?
Yes.
So let me thank Jojo sir for finding time in between his busy schedule and for offering us such a great opportunity to know more about the use of lasers. Many of us thought that the use of lasers were limited to few surgeries, but various applications like the diagnosis of several diseases, as he mentioned, were unknown. So this session enlightened us about the wide and inevitable applications of lasers in modern medicine. So honestly, sir,
This class was very informative and the presentation really made it easier to understand. Once again, thanking you, sir, for your sincere efforts and for inaugurating the activities of our Physics Association. Thank you, sir.
Thank you. Thank you, Adal.
Thank you, Atalia. Thus, we come to the end of the session. Thank you all for making this function a grand success. Thank you.